Good afternoon to everyone. Today we discuss about the Fourier series. Basically, Fourier series actually we discussed in our the previous lectures also. What's with the Fourier series, full range series, as well as also the half range Fourier series. And for the half range Fourier series, we discussed about in our the previous lectures, that was the sine series. And now today we discuss about the next one, that is the half range Fourier cosine series. So we discuss about the Fourier cosine series. So what is the Fourier cosine series and where it has applications? Actually, for the case of the electronics and electrical engineering, it has hugely applications. It has for mainly for the input function. Sometimes a device are required the input functions as the wave in nature. For that cases, it's required the Fourier series, and in particular case, that is the Fourier cosine series. And what actually the Fourier cosine series do? The half range Fourier cosine series, it will be the given function sometimes in the such a form of that f of x with the given function. That given functions converted into the form of the cosine terms. The parts will be converted in the series, that is the cosine terms, and it will be in the form of the infinite sum of the cosine terms. So actually the function fx that converted into the form of the only cosine terms as well as with some constant value, that will be the Fourier cosine series. Next, the constructions of the Fourier cosine series. How we can construct the Fourier cosine series? So for the half range Fourier cosine series, first it's given the one function f of x, that function fx, it will be just defined over the interval 0 to t. That means next for the finding out the suppose this is the one axis, coordinate axis, this one, and the functions fx be defined on the interval 0 to t, this 0 to t. Suppose here be the interval, the function is defined in this way. Suppose this is the function 0 to t. So target is that we have to convert these functions in a whole range. Whole range means in the interval up to the minus t to the plus t, this one. So how we can construct here the function? So we have to construct here the function in such a way that f of minus x will be equal to fx as the given function. That means if I plot here the graph, it will be in the form of this one. So that means here f of minus x here, and here f of x, this one. So this side, this is f of x, and this side f of minus x, this one. That means now the function is defined over the interval minus t to the plus t. So that means it is the even functions in the interval minus t to plus t. Now the function f of x is defined on the interval minus t to the plus t, and it is the even function. Because of that, we construct the function in such a way that f of minus x will be equal to fx. Next one, what is the Fourier series and its variables? That is the what will be the values of the a0, an, and bn. As we know, the general form for the Fourier series, f of x will be equal to this one, the Fourier series. As we already know what is the definition of the Fourier series, a0 by 2 an cos n pi x by t plus bn sin n pi x by t if the function defined over the interval minus t to plus t. So next condition is that what are the values of the a0, an, and bn? For the full range series, already we know this will be the values of the a0, an, and bn. Now consider here for the case of the given function defined in this interval, then a0, it will be there 1 by pi 1 by t minus t2 plus t fx dx. The function fx is the even function, So it can be written as in the form of 2 by t 0 to t f of x dx. This one, as the function is the even function, we know from the property of the integrations, this can be written as half interval 0 to t 2 by t, this one. That means a0 is nothing but this one. And next one, what is the value of the an? An will be equal to 1 by t minus t2 plus t f of x cos n by x by t. So here again the function fx is that the even function, and the function cos n by x by t, this is also the even function. So product of the two even functions, we know this is the even function again. So the property of the integrations, we know that it will be the 2 by t 0 to t fx cos n by x by t. So that means the value of the an will be equal to this one. So it automatically converted in this form. Another one, that what is the bn? Bn is nothing but the definitions minus t2 plus t f of x sin n by x by t. Now, according to the construction, the function fx is that the even function, and the sin this function is that the odd function. So product of the even function and odd functions, we know that is the odd function. So obviously this integrand portion is that the odd function. Therefore, the integrand portion is the odd function minus t2 plus t, its value will be the 0. So that means the value of the bn is nothing but equal to 0. So bn equal to 0. So this is our the construction. So we can consider here. So bn portion 0. So that means here the for the Fourier half range cosine series, this part will be cancelled and its value will be the 0. So ultimately the Fourier series will be converted into the form of f of x equal to a naught by 2 plus summation of these portions only. So n cos n by x by 2. So this is the Fourier half range Fourier cosine series, and for this Fourier cosine series we have to calculate what will be the value of a0 and an only. So this is our half range Fourier cosine series with a0 and an. Now we consider here the one example. What is the example? We consider here the one example f of x equal to pi minus x defined over the interval 0 to 1. And we have to find out the half range Fourier cosine series of this function. So what will be the Fourier cosine series? So this is the Fourier cosine series as we discussed in the previous slide. So this is the Fourier cosine series, and what is the value of a0? The value of a0 will be from here, value of a0 that is equal to interval 2 by pi here, because 2 by t is nothing but here the pi. So 2 by pi integration 0 to pi f of x means pi minus x dx. This is the fx, and if you take the integrations of this one, 2 by pi, this one, pi x minus x square by 2 interval 0 to pi. So this one, and when we put here the limit, for the lower limit its value will be the 0, and for upper limit it is the pi only. So pi square minus pi square by 2. So 2 by pi into pi square by 2. 2 cancel. So this is the pi. So that means the a naught, its value equal to pi. Next an, what is the value of the an? So an equal to, we consider here the formula an, this an, from this formula 2 by pi 0 to pi minus x into cos of n pi x by 2 by pi. This pi cancel हो जाएगा, so cos nx dx. Now we have to take the integration by parts. by pi integration. So pi minus x fixed integration of cos, that is the sine nx divided by n minus sine integration minus 1 cos of nx divided by n square. This part 0, for here the limit will be 0 to pi, that is the limit. For the upper limit and lower limit, for both cases its value will be the 0, that is the 2 by pi minus cos of n pi by n square minus plus lower limit 1 by n square. This is the value of this one, and it has the two cases, odd and even. When n is the odd, its value will be minus 1 to the power n, that means 4 by pi n square for n is odd, and 0 for n is even. This one. So we got here the values of the an. An will be equal to this one according to even and odd. So next we have to find out the Fourier series. That means we have to put the value of a0 and an in this. So after putting this value a0 and a1, we got here this value. This is the Fourier series, half range Fourier cosine series, putting the value a0 and an in this one. So this will be your the required Fourier half range cosine series. Now with the help of this series, we have to find out the value of this series, that is the value of this series will be equal to pi square by 8. We have to prove this one. So for this case, now if I consider x equal to 0, then what happened? Put here x equal to 0 here in this case. So when we put x equal to 0, it will be pi minus 0. This will be equal to pi by 2 plus 4 by 5 cos 0 1, that means 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus. So this will be the Fourier series, and now if I take on this side, this will be the pi minus pi by 2, that's equal to pi by 4 into 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus this one. Now the left hand side, it will be pi by 2, this equal to 4 by pi square plus this one. Now if I take this constant on this side, so it will be pi square by 8, this equal to 1 plus 1 by 3 square plus 1 by 5 square plus this one, and hence prove this one. equal to this one. So this is the one example for the half-line Fourier cosine series. So we can easily find out what will be the Fourier cosine series with the help of this definition. Now I consider another one example here. Another one example, if we consider here the another one problem, suppose fx equal to x square. This is also looking upon here the even function, so we can easily find out what will be the Fourier series of this function. So for that case, at first we have to find out the constant a0. So value of the a0, that will be equal to here 2 by pi, because here the limit is that up to 0 to pi. This is the limit, so 2 by pi integration 0 to pi fx means x square here, fx dx. So this one, so take the integration 2 by pi x cube by 3 0 to pi, that one, and cube by 3, its value will be 2 pi square by 3. So this is the value of the a0, and similarly we have to find out the value of an that's equal to 2 by pi integration 0 to pi fx means x square and cos nx dx, because here t equal to pi, so pi cancel ho jayega, it is the nx, this one. So next we have to take the integration by parts, 2 by pi x square first function fixed, cos nx integration sin nx by n minus derivative of the first function 2x sin x integration minus cos nx by n square plus 2 derivative of 2x and this is the 2 sin nx by n cube and limit 0 to pi. So now we have to put the limit, lower limit and upper limit for both the cases. This is the sine form and this is the sine function. Its value will be the 0 and its value also will be the 0. So only the middle portions will be there, and its value, if we put here the upper limit and lower limit, and for also the lower limit its value will be the 0. Lower limit also its value will be the 0 only for the upper limit. And for only upper limit x equal to pi, so when we put here only the upper limit pi, its value will be coming out minus 1 to the power n, that is the cos n pi. Cos n pi value minus 1 to the power n, 4 by n square. So this is the value of the a naught. Now what will be the series? So that means we have to put here series will be a0 by 2, that means here a0 is this one, a0 by 2 if we put here, so it will be pi square by 3, this one, plus summation of n cos this one. N means minus 1 to the power 4, minus 1 to the power 4, 4 by n square, this one, into cos of nx, this one. This will be your the series n 1 to infinity. So that means if I consider here, the series will be, after putting this one, the series will be x square will be equal to this one. This is the series. Now we have to again prove the value of the series will be equal to, this series will be equal to pi square by 6. So we have to put here the value of x on both sides in such a way that we get all the values will be here the positive, here also will be the positive. That means the negative signs will be converted into the positive. We have to put x in such a way there. So that means x equal to, if we consider the pi, so cos n pi equal to minus 1 to the power n, we know cos of n pi, that's equal to minus 1 to the power n, minus 1 to the power n. So that means we got here all value will be the positive. So it will be pi square left hand side and right hand side pi square by 3 plus 4. It will be cos 2 pi, this is the 1 by 1 square plus 1 by 2 square cos 2 pi, cos 3 pi minus plus, that means 1 by 3 square plus 1 by 4 square and plus that up to infinity. So now we have to rearrange it. That means pi square minus 2 pi square by 3, that's equal to 4 into 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus this one. Now, simple calculations are to cancel. So, pi square by 6, this 4 will be the left hand side, 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square and plus infinity. And hence, this one too, its value will be equal to pi square by 6. This is the proof. And in this way, we can easily calculate how to find out the Fourier series, Fourier cosine series, Fourier sine series, etc. And this will be some examples of. And thank you.